Remember in the last section we learned the local extreme value theorem, which says that if f has a local maximum or a local minimum at a particular point, and the derivative exists at that point, then the derivative has to be equal to 0, right? But just because the derivative is 0 doesn't necessarily mean that that point is a local minimum or maximum. We called it a critical point, and so in order to determine whether that critical point is a local minimum or a local maximum, or maybe neither, we need a test. And the first test that we're going to learn is the first derivative test. Now, the first derivative test is just based on the fact that the derivative tells us about the slope of the function, right? If the derivative is greater than 0, the function is increasing, right? The original function f is increasing. If the derivative is negative, right, that tells us that the function is decreasing, okay? So what we're going to do in this first derivative test is look at the first derivative, as you might expect, and once we identify those points where the derivative is 0, then we can evaluate the derivative on either side, right? We can look at points to the left and points to the right and figure out what the derivative is doing. Like so, right? So if the derivative is going from negative to positive, as it is in this first graph here, right? It's going from negative to positive. So the derivative or the function goes from decreasing to increasing, then we have a local minimum, right? Or if the derivative goes from positive to negative, like it is over here, positive to negative, the derivative is, or the function goes from increasing to decreasing, and so that that point where the derivative is 0 is a local maximum. All right, so let's take a look at this first example. Here we have a formula. We have a polynomial for a function, and we want to find the critical points and of the function and use the first derivative test to classify them as local minima, maxima, or neither. All right, so change to green if for some reason I'm not on green. Okay, so first thing we want to do is find the derivative of this function. So let's take the derivative. F prime of x is equal to what? 3x squared minus 18x minus 48, right? And we want to set that equal to 0. So let's factor it. Let's get rid of this 3. So then we'll have x squared minus 6x and then minus 16 when we factor out a 3, and then it's just much easier to factor what's left. So when we factor that, we'll have 3, and then it factors into what? X minus 8, and x plus 2, it looks like that will work. And then we can set it equal to 0. And so we'll find that we have critical points at x equals -2 and 8. Okay. Now, this is a polynomial, right? The derivative is also a polynomial, so there's no points where the derivative doesn't exist, so we don't have to worry about that case. All right, so now we're just going to apply the first derivative test to determine whether these critical points are maxima or minima. So let's do a test. I'm going to label it as test, okay? So that whoever's grading my work can find it easily, right? So so I want to let's look at first of all, well, actually, let's draw a little number line here as well, because just like we have in the past, so once we identify the critical points, those critical points divide the domain into 3 parts, right? We're going to divide the domain at -2 and 8, and then look at points in each of the three intervals of the domain. Okay, so let's start by looking at, let's do f at -3. Okay, f at -3. Now, I will give you a tip. It's always it's easier to look at the factored form, because all I really care about is whether the derivative is positive or negative. And if you use the factored form, and if all I care about is the sign, then I could just do a sign analysis, right? So I'm taking 3 times, now -3 minus 8 is going to be negative, right? I don't really care that it's -11, but it's negative, right? And then if I put in -3 over here in this second factor, -3 plus 2 is also negative. Now take a negative times a negative and you get something positive, right? So it's equal to a positive, which is greater than 0. Okay, so that's telling me that when x is less than -2, the function is increasing. All right, so I meant to put f prime. I'm evaluating f prime, okay, right? I'm evaluating the derivative. Okay, so I want to make sure that's clear. I'm evaluating the derivative to determine the slope in these different intervals. And I'm just picking a test point, right? So now I need to pick something between -2 and 0. All right, -2 and 0. So maybe 0. That's an easy one. That one I could easily just go back to the original form of the derivative. Or I could use the factored form. It doesn't matter on this one so much because I'm going to get a -48 no matter what. But let's go ahead and use the factored form, right? So I'm going to have a negative times a positive, which is negative, and that's less than 0. So the function is decreasing. So I'm just going to indicate that the function is decreasing on the number line with that little arrow that has a negative slope. And then finally, we got to look at the last interval and could just pick a point, something bigger than 8. So maybe we'll pick 9, right? And again, it doesn't really matter what point I pick, and I'm just really am concerned about the sign. So if I put in a 9, 9 minus 8 is 1, so that's positive. And then 9 plus 2 is also positive. So I get a positive, which is greater than 0, which means the function is increasing. So now I can say that based on my first derivative test, I can say that we have a local maximum at x equals -2. Right, and I have a local minimum at x equals 8. Okay, now this one doesn't really say. It just says to find to classify the points as local maximum minimum. Sometimes I ask for the x and y coordinates. Now, in order to find the y coordinate of the local maximum, I would have to go back to the function for, we could say this is y equals f of x, right? I could plug in f of -2 and get the y coordinate for that local maximum. So f of 2, let's see, I put that in my calculator, I get 104, right? That's telling me that the value of the function at -2 is 104. So that is the maximum value of the function, right? So, and I could do the same thing with 8, right? If I actually wanted the maximum value of the function, then I could plug in 8, put that into my calculator, and find I get -396. Okay, so if I actually wanted the minimum of the function, would be at that local minimum, right? Is -396. Okay, but it doesn't ask for that. It just sometimes I ask for just the x coordinate. Sometimes I ask for the x and y coordinates of the local minimum and maximum values, but this one doesn't really say, so I would just assume we can get by just finding the x coordinates. All right, I will meet you in the next video.